This is Quideo number 4 for AP Stats. So we're talking about the Census Bureau, and it reports that households spend an average of 31% of their total spending on housing. A home builders association in Cleveland believes that this average is lower in their area. They interview a sample of 40 households in the Cleveland metropolitan area to learn what percent of their spending goes toward housing. Take U to be the mean percent of spending devoted to housing among all Cleveland households. We want to test the hypothesis. So this equation represents the null hypothesis, and this equation represents the alternative hypothesis. The population standard deviation is 9.6%. A. What is the sampling distribution of the mean percent X that the sample spends on housing if the null hypothesis, the first one, is true? Sketch the density curve of the sampling distribution. So, as you can see, I got that the sampling distribution, I have 0.31 because it's based on 31%, and 0.0152. In order to get that, we had to set up this equation, and you had 9.6 divided by the square root of n, and n was 40 because there was 40 households. It was the sample size. And as the result, we got 1.518%, or as a decimal percentage, 0.0152. This is my density curve that I drew for it. You start with 31%, I put them all as decimals here, and they're each going up this amount. So it goes from 0.31 to 0.3252, etc. And here's my work for that. The standard deviation is given. It was 9.6% or 0.0960. This was the null hypothesis. This was the alternative hypothesis. We have to assume normality and assume SRS, simple random sample, and proceed with caution due to the size because it was not stated. For B, it says suppose that the study finds X to be 30.2% for the 40 households in the sample. Mark this point on the axis in your sketch. Then suppose that the study result is X equals 27.6%. Mark this point on your sketch. Referring to the sketch, explain in sample language why one result is good evidence that average Cleveland spending on household is less than 31%, whereas the other is not. So I sketched these in on my graph, and here's the 30.2% and here's the 27.6%. Average Cleveland spending on housing being less than 31% would be evident based on the 27.6 rather than the 30.2 because the 30.2 is much closer to 31% and is fairly likely to occur merely by chance. We would fail to reject the null hypothesis. 27.6 is unlikely to occur just based on chance, and we would reject the null hypothesis. This is because our result is significant at level alpha. In order to reject something, it has to be less than, and failure to reject has to be more than. Part C says shade the area under the curve that gives the p-value for the result x equals 30.2. And so all of this, you find 30.2% based on this curve, and less than, so you go down and shade everything to the left. For the advanced question, Pew Research in November 2011 polled a random sample of 799 U.S. teens about internet use. 49% of those teens reported that they had misrepresented their age online to gain access to websites and online services. A. Find the margin of error for this poll if we want 95% confidence in our estimate of the percent of American teens who have misrepresented their age online. So our sample size was 799, and parameter, also known as N, would be the 799 U.S. teens about internet use. we have to consider the rule of thumb. So because it's proportion and not population, we have to make sure n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. And as you can see, we did both, and they were much larger than both of those margins, so we can assume with this problem. To find the margin of error, since it's 95% confident, we would use the z-value of 1.960, and 49% is essentially the same thing as 0.49. So that would go right here. The complement of that would go right here. Our z-value goes in front, and the bottom number is our parameter, also known as n. And our answer would be 0.0347, which means we can be 95% confident that 49% of those teens misrepresented their age online, plus or minus 3.47%. Both rule of thumbs were met. 49% plus or minus 3.47 gives us this margin. So we have from 45.53 to 52.47 percentage-wise. Margin of error means the percentage or amount that is allotted for error or miscalculations. Confidence interval width essentially would be the same thing. In context for this problem, it is the percentage of people who calculated wrong their misrepresentation of age online to access websites and online services. Essentially, the flaws within this random sample. So those not accurately depicted. The AP question: each person in a random sample of 1,026 adults in the United States was asked the following question. Based on what you know about the Social Security system today, what would you like Congress and the President to do during the next year? These were all the responses. As you can see, they don't add to 100%, but rather 70%. For A, find a 95% confidence interval for the proportion of all United States adults who would respond, make some major changes. Give an interpretation of both the confidence of the confidence interval and of the confidence level itself. So our sample size was 1,026 adults. Our parameter, also known as n, were adults in the United States asked what Congress and President would do during this next year. The response choices and percentages only add up to 70%. A, make major changes. 39% or 0.39 voted for that. And the Z score associated with 95% confidence interval would be 1.960. Here's our N and P. We have to multiply those together to make sure it's greater than 10 to proceed, and it is. So there's our first rule of thumb. Our second one, we calculated right here using the complement, and it was also greater, so we can still proceed. This is our margin of error, 0.0298, which means we can be 95% confident that 39% of the responses voted for making some major changes, plus or minus 2.98%. Both rule of thumbs were met. 0.39 plus or minus 0.0298 gives us our confidence interval, so our range is 0.3602 to 0.4198. The confidence, 95% of the confidence interval, means we allow for room for error, miscalculations, or changing conditions. This essentially allows for 5% of wrong statistics. Hard to be 100% right or confident. B, 39% voted for major changes. 41% voted for minor or no change. That was the scenario for the after part. The before part, 30% plus the 1% for no change gave us a total of 31%. While this statement shows we should not change the system is technically correct, it is misleading because there is only a 10% change because it went from 31% for minor or no change to 41%. Also, the difference between making major changes and minor or none is very little. If you still were to combine people voting for making major changes or overhauling the system, changing the system would still win. So while they make it appear like it would be a good idea to not change the system, in actuality, according to these responses and stats, more people voted if you add the completely overhauling the system and making major changes in comparison to leaving it how it is. All right, that's it. Thanks.